interesting topic. So today I'll be talking about what we call the Shanky diagram or the Sankey diagram, depending on your accent or how you want to pronounce it. I'll be showing what I'll be explaining what the Shanky diagram is and how you can use it, how you can apply it in your work as a student or um, in your professional work as well. Um, so um, I'll be using a hybrid car as a case study in this talk to just to explain how you can apply the Shanky diagram. So when we talk about Shanky diagram, I want you to think about the diagram that it's a type of flow diagram that can help you visualize the flow of resources, energy, material, or information within a system. For instance, if you want to um, if you want to understand the flow of, let's say, energy within a hybrid car, for instance, which we'll be using as our case study today. We all know that a hybrid car is powered by both the battery and the fuel source. So these are the two ways, the two energy sources in a hybrid car. And so if you want to understand, let's say, the contribution of each of these energy sources or the efficiency of, for instance, the battery and the fuel efficiency in a hybrid car, this Shanky diagram can give you a representation, a flow diagram of how the energy um, is being consumed within the hybrid car. So you can trace the consumption path of the energy to know which system is using more energy, sorry, than other systems. For instance, in a hybrid car, and we expect the engine, of course, the internal combustion uh, engine to use more of the energy in doing the work that drives the car. But that's just one example, but that's the beauty of the Shanky diagram. That's what it can help us to understand the flow of materials, the flow of energy. So when you're talking about something like material balance, for instance, material balance of a system tells us the materials coming in and leaving a system. But if we really want to understand how the materials are utilized in the system, what part of the system uses more material than the other parts, then you need to represent the flow of the material using a Shanky diagram. And the beauty of a Shanky diagram is that the width of the arrow can actually tell us the quantity of the flow. For instance, if you consider the width of this arrow that represent the battery in comparison with the weight of this that represent the fuel, you can see that from the fuel source is higher, is larger than that of the battery. So from here you can clearly see that for a hybrid car, the heat or the energy from the fuel source, from the fuel, I mean the petrol, and I use the word fuel now. I mean the petrol or the diesel or wherever you're using to power the hybrid car or hydrogen. The energy from that, it's higher than the amount of energy that comes from the battery source. So that's what we're learning from this diagram. And again, we can see this. Um, okay, I'm going to explain what all these rectangles mean. They are called nodes, actually. So the fuel source from the petrol goes to the engine, and you can see that the fuel is used from the engine to power the wheels of the car. We're going to see a better representation of this diagram. Then other parts of the fuel is used in charging the battery. And at the same time, the battery in the hybrid car is also some power from the battery is used in driving the car or doing other functions within the car. So let me just explain the key component of a Sankey diagram before we go on. Just like I said, the nodes are the rectangles we see on the Sankey diagram. So these nodes, they represent the sources. So that, for instance, the energy source, the battery source, the fuel source. These are what they represent. These nodes can be sources, they can also be sinks or intermediate stages in the flow. Another thing we see is the arrow. The arrow represents the flow of something. Um, so it's telling us the flow of material from one node to another. And the width of the arrow, just like we said, is proportional to the quantity of the flow, making it easy to visualize the distribution of resources. Another thing we see in this Sankey diagram is the flow can be unidirectional or bidirectional depending on the type of system being depicted, and they show the direction of the flow of the resources. Another thing we see on the Sankey diagram is that we have labels, and these labels can be added to the node and arrows to provide more information about the components and the quantity of flow. So the common applications of Sankey diagrams, just like we stated earlier, when we try to see the energy flow within a system or within a power plant or even within your building, for instance, in your house, you want to understand which part of your equipment or which of your equipment is using more energy. You can use a Sankey diagram to do the analysis of the energy consumed by each of your equipment. It helps you to understand the flow at every given time. So you can also use it to understand the material flow in the system. We can also use it to understand the environmental impact. So we can illustrate the environmental impact of a product or process using the Sankey diagram. For instance, if we want to understand the carbon emission from a process or a system, we can use the Sankey diagram to trace the carbon emitted along the life cycle of a product or a process. And so that's the beauty of this Sankey diagram. We can also use it for cost analysis. I mean, every country do what is called the annual budget, and so you can use a Sankey diagram to see the amount of resources being allocated to different sector of the economy. And so you can use it to evaluate, to do a quick evaluation of a country's budget or your household budget or your own personal budget. Now let's see how we can implement this using Python. And this is another beauty of Python. The fact that we can actually plot this type of unique charts in Python. So the first thing we want to do is that I don't teach Python this way, but the first thing we want to do is to install the Plotly library. You want to make sure that that is installed in your Python, and you define the nodes and the links, and calculate the energy flow. Then you have to create a dictionary to describe the Sankey diagram, nodes, and the link attribute. So I'm going to show you how that code will look like in this diagram. So you can see from here, I've installed my Plotly, so I can now say import plotly.graph object as go. So you just make sure that Plotly library is installed. Then you want to define the nodes and the links. So you can see that the nodes represent what um, the fuel sources and how the fuel will be used. So we have the fuel source, which, let's say it's a petrol hybrid car, so which will be petrol, of course. The battery, the engine, the wheels, the battery usage, the fuel usage. So we want to track the flow of energy um, within the system. So we say the energy from the fuel source 100. We just give it a value of 100 at the beginning, and we say the battery efficiency 60%, the engine efficiency is 50%. So um, just like we know that the battery efficiency is always higher than the internal combustion engine efficiency, so this is a reasonable assumption to make in this Sankey diagram. So we calculate the battery usage as a fuel usage times one minus the engine efficiency. The same thing we do, the same thing. All this helps us to calculate the energy flow within the system. But this second part is very important for us to um, label the links. So we create the link label. So after doing that, we come to this part where we need to create like a dictionary. So if you don't know how to do that in Python, you can look online for other videos. Basically, we're just trying to specify, given just to give some specification of what we want our nodes to be like. So we define how we want our nodes to be, the thickness, the pad, the line, the labels, then how the link should be. So the link is the source, the target, and the value. So these are basically what we specify. So if we put it all together and run our code, we're gonna have something like this. I'm gonna show you a much better version of this in the next slide. But let's read what we have below. So the battery usage represent the energy drawn from the fuel source to charge the battery, and the fuel usage represent the energy used directly by the internal combustion engine. So what it's saying is that if you look at this bit, the engine is, you know, directing some energy to the fuel source, and the same engine is also directing some energy to charge the battery. So, but at the end usage year, we expect this to go to the wheels of the car, because that is what is going to power the wheel. So I'm going to show you a much better diagram that can explain that this is it. And this is the beauty of Python. You don't get this kind of chart in order um, um, using other application, or you can get it, but it's going to be extremely difficult. But actually Python can do this for us. So if we do that, you can clearly see the diagram now, that the fuel coming from both the fuel, actually this fuel source combines both the battery and the fuel source, and so you can see that there's a part of it that goes to the engine, and there's a part of it that goes to the battery, and all of them power the wheels. And this is a true representation of what is happening in the hybrid car. So I thought I should just share this video on how you can use Sankey diagram. Or if you want to learn more about Sankey diagram or anything about, maths or physics, chemistry, assessment, IB, GCSE, nationals, just get in touch. Get in touch with us. We'll be very happy to hear from you. Enjoy the rest of your week or weekend, as the case may be. Thank you.